चालू ही रहेगा अभी आधा घंटा. Good afternoon, friends. We are into this lecture under AICT's Prerana coaching for the entrance exam to IIT, that is the GATE. Syllabus that has been allotted and will be discussed today is regarding the hydrology, that is the hydrologic cycle, precipitation, evaporation, evapotranspiration, watershed, infiltration, and unit hydrographs. So let us see how much we can cover within this duration of 1 hour, or we'll say it will take a bit more. Regarding unit hydrograph and hydrographics and the remaining part, we will discuss into the next lecture. Friends, we all know that the water is the important part of our life, and therefore the living organisms and the thinking organisms like the human beings, they have always this question in mind since centuries, that where from this water comes, where it goes, why the some water is salty and some is fresh, why sometimes there is not enough rainfall and sometimes there is excess rainfall. And all this human culture or all human beings are 101% depend on the water, because without water we cannot live for an hour. So therefore that is the importance of water, and all the cultures from the Mohenjo-daro, Harappa to, you can take your small towns and cities and villages, all are situated almost on the river banks or on the river, nearby the river, so that we should get the permanent water supply. So all these questions related to the water are being covered in this subject that is called as the hydrology, wherein this hydro and the logy, both these words have originated from Greek alphabets. That is, hydro means water and logy or logos means science. Therefore the hydrology word has evolved from this. So definitely it is the science of water. Okay. This science deals with the occurrence, means where from this water comes, the circulation, how this water gets circulated in different forms, maybe a liquid form, maybe a solid form, or maybe a gaseous form. So this is being studied in this subject, which is called as the hydrology, that is the occurrence, circulation and distribution of water on the earth and the earth's atmosphere. And as I have been telling you again and again, a very good understanding of this hydrologic process or the hydrology helps us in exact assessment or exact finding of the quantity of the water that will be available, that we can assess in advance, so that we can manage that water which will be available to us. And also the conservation of water on the local scale, district scale, regional scale, on country scale. has become a very important subject nowadays, because the nature is now very fluctuating. Sometimes it rains very heavily, and sometimes there are certain patches or certain periods when the rain does not occur. So conservation of water is also very important. So engineering hydrology deals with the estimation of the water resources. It includes, or the study process includes, precipitation, that is the rainfall in our from our sense, evapotranspiration, that is the evaporation and transpiration, the runoff, and what is their interaction with how they are related to each other. Then the question of the floods, because due to this excess rainfall for a longer duration, the water crosses the banks of the river and encroaches outside the banks and destroys not only human and the animal life, but also the other properties also, like that is the agriculture, the houses, roads, bridges, etc. So on one side, the hydrology helps in tackling the floods, as well as on other side the droughts, that is the famine, जिसको हम हिंदी में अकाल करके बोलते हैं. तो बहुत बार जब बारिश नहीं आती है, बारिश बहुत कम आती है, तो we face the problem of droughts. And if we have the proper study of all this hydrology, that is the science which deals with the occurrence, distribution of the water and circulation of the water, then we can well in advance plan the strategies to face these two problems of the floods and the droughts. Now, a very simple term, a simple phenomena we will try to understand: the hydrologic cycle. Friends, we all know, as I have told you just now, that water exists on the earth in three states, that is the liquid, solid, and the gaseous state. And in all these three states, the water has the tendency to move from one place to another. Okay? So it is always has the property of dynamism, that is the movement. It has got this movement property, that is dynamic aspect it has, or it has a dynamic nature. So due to this dynamic nature, that is the movement property, as well as the three states of the water, that is existence of water in liquid, gas, and the solid state, a very nice natural phenomena occurs. That natural phenomena is called as the hydrological process, or that is also that hydrological process is called as the hydrological cycle. Okay, so a very beautiful natural phenomena which is the result of the hydrological process, called as the hydrological cycle, by means of which the water in the liquid states gets converted into the gaseous state due to evaporation from the water body, that is like the ocean, seas, rivers, reservoirs, lakes, due to the solar radiation, due to the solar heat. And after this water gets converted into the vapor state, that is due to the evaporation, its density being less than the air, it moves upwards, and after reaching certain height, these vapor particles, being very light in nature, They flow with the wind which is called as the flowing air. They flow with the wind, and from the water body they reach to the land, sometimes land. And when all these evaporated water particles, that is the vapor particles, they come very close to each other, due to the cohesion of all these vapor particles, a scientific process called as condensation occurs. Condensation means accumulation of the water vapor particles or molecules at one place, resulting in formation of the clouds. And when all these clouds comes very close to each other and they become very dense, and if the atmospheric temperature at that height, cloud height, is too less, it is cold, then this condensed cloud particles gets converted into the water particle, or sometimes to the ice particles. And these water particles or the ice crystals, the ice particles, being heavier than the air due to the gravitational force, they fall over the earth, maybe on the water body or maybe on the ground or the soil part. And after it falls, this falling of the water particle from the clouds to the ground is called as the precipitation. Okay. So this precipitated water falls on the ground. Either water precipitation not only includes the fall of the water particles, raindrops we call it as, but it also includes the fall of the ice particles also. So it rains, it precipitates on the earth, and after falling over the earth, the water particle saturates the soil surface. It fills all the voids of the soil surface, and then some water percolates into the ground, which is called as the infiltration. Some part of the water which is infiltrated also follows the topography of the ground, and after saturation of the soil at the top, the water on the precipitation water, some part of the precipitation water follows the stream, the rivers. They are called as the surface runoff. The water which percolates into the ground and follows the topography of the ground is called as the subsurface runoff. And certain part of the water, due to the gravity, percolates or infiltrates below the ground surface, and it reaches the groundwater table and raises the groundwater table is called as that runoff is called as the groundwater flow, or that runoff is called as the base flow. And after this water from the surface as well as subsurface runoff reaches to the stream or to the water body, maybe ocean, maybe a sea or a lake or a reservoir, again due to the sun rays, due to the solar radiation, this water which is in the liquid form gets again converted into the vapor, and again this vapor gets converted into the clouds, movement of the clouds, and again falls on the ground, precipitation, condensation, cooling, precipitation. So this process is called as the hydraulic cycle, hydrologic cycle or hydraulic cycle. So it includes all these uh, parts, that is evaporation from water body, water vapor moves upwards, cloud formation, condensation, precipitation, interception, transpiration, infiltration, runoff, deep percolation, groundwater flow. The hydrologic cycle is very important to our day-to-day life. It is important from the point of view of agriculture, forestry, geography, economics of the country, of the world, depends on the precipitation, the rainfall, sociological and political scene. From our engineer's point of view, the hydrologic study or hydrologic cycle study is important from our hydraulic structures for the design and operation of the hydraulic structures like the dams, bridges, aqueducts, etc. for water supply, domestic water supply as well as for the irrigation and drainage purpose, hydropower, flood control, navigation, coastal works, salinity control, various hydraulic structures, recreational use of the. This is in short the sketch of the hydrologic cycle. Friends, you all are aware about one of the term called as the catchment area. The water, the precipitation after falling over the land, the part of the precipitation which falls over the land to a certain area which supplies 100% water, that is the surface as well as the subsurface runoff, as well as the base flow, that is the groundwater flow, groundwater runoff. That part or that area which supplies water to certain stream is called as the catchment area. The catchment area is separated by the ridges. The catchment area or watershed, it is also called as the drainage basin, is defined as the area that appears on the basis of the topography to contribute all water that passes through the given cross section to the stream. I always show this picture to distinguish the catchment area. This is the ridge. As I have told you just now, this ridge divides the catchment area of this stream as well as this stream. That is, the catchment area is nothing but all this area between this ridge and this ridge for this stream, over which when the rainfall occurs, the water reaches to this stream, as well as for this stream also, this ridge and this all these ridges. In between, all the area over which the rainfall occurs, it reaches to the stream. I also show this media presentation to understand the catchment areas as has been shown by this red color and the blue color boundary lines. That is the watershed or catchment area of this stream, watershed and catchment area of this stream. Various types of the catchment areas are there: fan-shaped catchment area, firm leaf-shaped catchment area. Then we will move on to the next part, that is the precipitation as one of the important component of the hydrologic cycle, that is the precipitation. In our precipitation is nothing but the all forms of the water, maybe a liquid form, maybe a gaseous form, vapor form, or maybe a solid form, that is the ice form, that reaches the earth from the atmosphere is called as the precipitation. The usual forms of the water which falls or which reaches the earth from the atmosphere are the rainfall, which we regularly experience in our area, the snowfall, the frost, the hail and the dews. Okay, फ्रॉस्ट को हम हिंदी में या मराठी में उसको धूका करके बोलते हैं, धूका. हेल मीन्स इसको मराठी में गार पीट होती है तो उसको हेल बोलते हैं. और ड्यूज आपको सबको मालूम है कि जो द the vapor particles which gets converted into very small tiny water particles, they are called as the dews. The first two, that is the rainfall and the snowfall, contribute to largest quantity or amount of water that has been available, that is being made available on the earth. And rainfall is considered or is usually called as precipitation in our region. The essential requirements of the precipitation or the rainfall. The atmosphere must have moisture. Okay, the atmosphere must have moisture. Moisture means water vapor concentration. So more water vapor concentration, more are the chances of occurrence of the precipitation. Condensation nuclei is very important thing which is needed for the precipitation or the rainfall. These condensation nuclei are nothing but the very micro salt particles, or certain particles which are products of the combustion, or maybe are part of certain lightning, or you can say very micro or tiny particles of the dust. These are very necessary for the rainfall to occur, because the raindrop or the water particles adheres to these salt particles or to these dust particles. They become bigger and bigger. As they become large, then and only then they become heavier than the air or the wind, and then with the help of the gravity they reaches to the earth. So therefore condensation nuclei is the must to form the droplet. Large scale cooling is also one of the requirement. Unless and until the cooling appears, the conversion of the water vapor particles into the droplets of water as well as into the ice could not take place. So therefore cooling is necessary. And other meteorological factors such as the wind, temperature, humidity, atmospheric pressure, etc. These are needed for the precipitation to occur. Various types of the precipitation are there. They are the cyclonic precipitation, convective precipitation, orographic precipitation, and precipitation due to turbulent ascent. Okay. We generally correlate precipitation to the rainfall. So the rainfall that occurs on the earth or reaches to the earth by various processes. Those various processes are divided or are called as the types of precipitation, various phenomena. They are the cyclonic, convective, orographic, and the precipitation due to the turbulent ascent. When the hot air along with the water vapor comes in contact, or it flows from the water body like the sea, and it reaches to the land and comes in contact with the cooler and the denser atmosphere, there is a front or a layer formed between the hot water vapor or the warm air and the cold air, and this front acts as a sliding plane, and this hot air or warm air moves upwards, reaches to certain height where the temperature is too cool, because almost with 1 kilometer rise above the earth, the temperature reduces almost by 5 to 6 degrees. So as we move upwards, the temperature reduction is evident, and therefore the cooler, more is the height from the earth, cooler is the atmosphere. So this warm air along with the water vapor reaches to that height and then converted into the water particle, and the phenomena of precipitation, that is the fall of this water or the ice particle to the earth, occurs. This process is called as the cyclonic. This type of the precipitation is called as cyclonic precipitation. This is further divided into frontal or non-frontal precipitation. The next precipitation is called as the convective precipitation, wherein again the phenomena of reaching the warm air along with the water vapor or the clouds reaching to certain cooler height is there, and after cooling the condensed clouds converts into the rain. This is common in all the four types. Only here no such fronts or frontal phenomena occurs, as has been discussed earlier, but it is only due to natural rising of the warm lighter air in colder or the denser surrounding occurs. Natural raising. And again the same condensation, cooling, and the conversion. This is the convective precipitation. The next is orographic precipitation. This orographic precipitation occurs into the hilly area or into the mountainous area. As has been shown here, the clouds, it is also shown in this sketch also. The clouds moves towards the mountains, and as the peak of the mountain is much higher, it is at much higher elevation, that these clouds cannot cross to this peak, and therefore they get accumulated. They get accumulated before this mountain peak, and after accumulation the condensation occurs, and the condensed clouds, which are bunch of the water vapor particles, they get converted into either to the water particles, raindrops, or to the ice particles, and they fall or they reach to the earth in the form of the precipitation. This is called as the orographic precipitation. In the Himalayan region, northern region, as well as into the Sahyadri ranges alongside the Konkan and the Kerala and some part of the Karnataka, the rainfall that occurs is due to this orographic precipitation. And last but not the least is precipitation due to turbulent ascent. Sometimes, again, due to the atmospheric changes, formation of the turbulent air movement, the warm air gets lifted over the cold air part due to the atmospheric movement like the hurricanes, etc. And due to this turbulence, the rainfall occurs. That rainfall is called as the precipitation due to turbulent ascent. Whatever rainfall that occurs due to the hurricanes, या जिसको हम मराठी में वादळ करके बोलते हैं, that rainfall occurs as a result of this turbulent ascent. Various types or various forms of the precipitation are the drizzle, rain, glaze, sleet, snow, snowflakes, and the hail. Okay. A drizzle, these are the various types, you can say, of the precipitation. Drizzle means very small water droplets which falls over the earth. They are less than 0.5 mm diameter, and the intensity is 1 millimeter per hour. Rainfall, as we call, the raindrops are more than 0.5 millimeters diameter. The intensity is also more than 1 millimeters per hour. When the drizzle or the rain freezes and gets converted into the ice flakes, it is called as the glaze. The rain is also further divided, or the precipitation, rainfall, is further divided into three parts. That is the light rain, moderate rain, heavy rain, again depending on the rainfall intensity. Now the measurement of the rainfall. As all these hydrological cycle and the hydrological events are very much important for us from the point of view of the design of hydraulic structures. Therefore, the necessity to measure the rainfall, how much precipitation has occurred. So the rainfall is measured in terms of the depth, and it is expressed in millimeters or in centimeters. 1 millimeter of the precipitation represents the quantity of water needed to cover the land with a 1 millimeter layer or thickness of water, taking into account that nothing is lost through drainage, evaporation, or absorption. Now, how the rainfall is measured? There are various instruments which are used to measure the rainfall in, again, depth, that is centimeters or the millimeter, wherein the following rain, the precipitating water is collected and is measured in terms of the depth in the equipments called as the rain gauges. There are very important aspects that how to select the rain gauge station, means where this rain gauge is to be installed. What is rain gauge station? Rain gauge station is nothing but the location or the area wherein these rain gauges or rainfall measuring equipments are fixed. It should be in an open place. That rain gauge station should be in open place. The distance between the rain gauge and the nearest object, like the tree or like the building, should be at least twice the height of the object. Means the distance between the rain gauge station and the object, that is like the tree or any building, should be at least more than double the height of that object, that is the tree or the building, but should not be in any case less than 30 meters. 30 मीटर से कम नहीं रहना चाहिए. It should never be situated on the side of top of hill. If we want to locate the rain gauge station at the hills, then as far as possible find the level place or level space. So that the ultimate thinking is that the rain falling or the precipitation occurring should not be obstructed. And last but not the least, that all these rain gauge stations must have a barricade or the compound or the fence, so that no external disturbance either from the man as well as the animal should be there, so that the accuracy in rainfall measurement will be affected. There are two types of these rain gauge stations or the rain gauges. They are the automatic and non-automatic type. In non-automatic type, the equipment or the rain gauge that is used is the Siemens rain gauge. In automatic rain gauges, the weighing bucket type the rain gauge, piping bucket, float type rain gauges, These are the various rain gauges are there. Okay. This is the sketch of the Siemens or the non-automatic type rain gauge. In our India, generally, this rain gauge being robust in nature, it is used all over the Indian meteorological rain gauge stations. Now, certain automatic or recording type or the graphic rain gauge equipments are there. They are the weighing bucket type rain gauge, wherein the basic fundamental is the collected rain, either weighing bucket type, tipping bucket type, or the third one is the float or the siphon type rain gauge is there. The fundamental is the water or the rainfall or the precipitation is being collected either into the weighing bucket or the tipping bucket or into this float type in certain container, and that contain the water quantity is being calibrated with the help of certain graphs and the pens continuously for the 24 hours or maybe for the days together, so that there will not be any interference of the human or the animal, and we will get automatically the quantity of the rainfall. Last but not the least, nowadays the rainfall or precipitation is also being measured with the help of the radars. This is the latest technology. It gives very accurately the distribution, that is for how much area the rainfall or precipitation is being distributed. It also gives the intensity, that at what intensity the precipitation is being occurring, as well as it also gives the quantity of the precipitation. How much rain gauge stations are to be provided in certain catchment area is being finalized, or the guidelines are being given by the Indian Standard Code or Bureau of Indian Standard Code 4987/1968. Okay, wherein they have said that for 520 kilometers square of the plain area or the catchment area, one rain gauge station can be provided. For the average hilly area, which has got 1000 meters and above height, for that 260 to 390 kilometers square area, for this area, one rain gauge station can be provided. And for very hilly region, mountainous region, for 130 kilometers squares of the area, one rain gauge station should be provided. The optimum rain gauge stations to be provided in certain catchment area is given by the Indian standard by this equation or by this formula n, that is the maximum number of rain gauge stations, is equal to coefficient of variation divided by the percentage of error in observation of the rainfall permitted. This ratio, and if it is squared, the square of this ratio will give you maximum number of the rain gauge stations that are provided into the catchment area. The coefficient of variation is being found out by the formula CV is equal to delta x upon x bar into 100, wherein delta x or Sx is called as the standard deviation. The standard deviation is also given by certain formula, Sx square is equal to xi minus x bar whole square upon n minus 1. So all this procedure is being adopted based on the number of the existing rain gauge stations and whether additional rain gauge stations are needed to find out the exact quantity of the rain gauge into the certain catchment area. Because friends, the exact quantity calculation of this rainfall is very important from the point of view of finding the exact quantity of the runoff, which is very important from the point of view of designing the hydraulic structures. This rainfall data may be available for one day, may be available for 1 week, may be available for 1 month, 1 year, or for 100 years, or for 20, 50 years, is being reported or is being prepared in various forms. That is called as the presentation of the rainfall. They are either presented in hydrograph form or hydrograph method, mass curve of the rainfall, point rainfall method. These are the various methods. Hydrograph is very important. It is the graph between the duration, maybe in seconds, minutes, hours, weeks, days, month, year, to rainfall intensity. This graph is called as the hydrograph. The another very important is mass curve of the rainfall. Again, it is the curve between the duration and cumulative rainfall. So this is very important. The third is point rainfall method. That is the rainfall from the individual rain gauge station maintained daily. Then for finding the average rainfall or precipitation over a certain area, there are three methods. They are called as the arithmetic mean method, method of the Thiessen polygon, and isohyet method. In arithmetic method, whatever number of the rain gauge stations we have, that is capital N, and the precipitation data from those rain gauge stations for a certain duration or period is added and divided by the number of the rain gauge stations will give you the average precipitation over a certain catchment area. The another method is Thiessen's polygon, wherein the catchment is subdivided based on the weightage given to the rain gauge stations, as has been shown here by the red dots, and the catchment is shown by the dotted line. So for all these rain gauge stations or rain measuring stations, which area is being important from that rain gauge stations, that is called as the weighing of the area, is being done by certain scientific method, wherein all those are joined, their perpendicular bisectors are drawn, they are connected, and then the weighted area or weighted area, as has been shown here for the P1 rain gauge station, A1 is the weighted area. For the another P2 rain gauge station, this is the another area. So in this way, all the areas are found out. And again, a formula which is equal to P1 into the concerned weighted area plus P2 into concerned weighted area, and so on, divided by the total area, will give you the average or the mean precipitation over the catchment area. This is one of the solved numerical over the. And the third or the last is the isohyetal method. Isohyet, friends, is a line joining points of equal rainfall magnitude, is called as the isohyet. As like the Thiessen polygon, the whole catchment area is again further subdivided between the various isohyets and is being weighed according to those isohyets. And again, that area multiplied by the area which is bounded by two isohyets of rainfall intensity P1 and P2. So average of these rainfall intensities of the isohyet multiplied by that area. In this way, all areas and their corresponding average precipitation average, it is being worked out, and the overall average precipitation is being found out. The interpretation of the rainfall data is done in the four types. This is very important. that is the intensity of rainfall, duration, frequency, and areal extent intensity of rainfall. Intensity is always measured in centimeters per hour. Duration is measured in either minute, second, or hour. Frequency of rainfall is the number of times that given magnitude of rainfall may occur in certain duration. That duration may be 10 years, 5 years, 50 years. That frequency of rainfall is very important from the probability of occurrence of particular rainfall quantity. So that for statistical study, to find out how much rainfall intensity or how much rainfall quantity will occur within 50 years, within 100 years, that maximum quantity will help us to find out the floods. And that return period or recurrence of that rainfall, that is called as the recurrence interval or the return period. Now friends, we will move into the next component of the hydrologic cycle, that is the evaporation. Very important, because in evaporation maximum part of the precipitation water gets lost, because we are interested in conservation of the precipitation water. But in evaporation, due to the solar radiation and solar heat in our India, maximum water is lost. So therefore the study of evaporation is very important. It is measured in millimeters per day, centimeters per day. So it is the method wherein the water vapor, the water in the liquid form gets converted into the gaseous state due to the solar radiation, due to the heat which is being provided with the help of the solar radiation. And almost 90% of the water is lost in evaporation. The mechanism of the evaporation process is that the water molecules which are there at the surface of the water body gets external heat energy, thermal energy from the atmosphere, or sometimes it gets the thermal energy from water body itself. And due to this thermal energy, the molecules at the water surface get kinetic energy. They start moving, and when their kinetic energy reaches to certain value, wherein now they cannot remain in the at the water surface of the water body, then they leave the water surface, gets converted into the vapor against the intermolecular forces of the water particle, and they get ejected into the atmosphere. This is called as the evaporation. The heat, which is the heat either from the atmosphere or from the water body, that is being used for the evaporation, is called as the latent heat of evaporation or latent heat of vaporization. It is denoted by L. As I have told you, either they get the energy from the atmosphere, or sometimes they get the energy from the water body and converts the water body into the cooler temperature. So therefore, in evaporation, the water gets cooled also, and the atmosphere also gets cooled. So evaporation is, though gets conversion of the water vapor into the conversion of water particle into the vapor state, but it cools either the water or to the atmosphere. The pressure that has been created by the water vapor particle over the water surface is called as the vapor pressure, which is the vapor pressure, which is the summation of the pressure due to the vapor molecule plus atmospheric pressure. When this vapor molecules gets concentrated over the water surface, and at certain stage, this vapor cannot accommodate additional water vapor, that pressure is called as the saturation water pressure. And when this pressure over the water surface reaches the saturation water pressure, This water vapor does not allow the water from the water body to convert into the vapor. This state is called as the equilibrium state. And when this state reaches, the evaporation process decreases. So therefore, for the evaporation to occur, always the vapor pressure EA should be less than the saturation vapor pressure. There is one law based for the uh, process of the evaporation, that is called as the Dalton's law of evaporation, which gives the evaporation loss millimeters per day. ES is the saturation vapor pressure, EA is the actual or the atmospheric vapor pressure, normal vapor pressure. So the deduction of this multiplied by the constant C is given by this. It gives us the evaporation loss. This is derived by Mr. Dalton. Then various factors are there which affects the evaporation. The again meteorological or atmospheric pressure, atmospheric factors, that is nature and size of the surface area, depth of water, humidity, wind velocity, temperature, atmospheric pressure, quality of water, solar radiation. Various factors are there. They can also be divided into the meteorological, the uh, soil surface characteristics, the water quality characteristics. So as we have seen, almost 90% of the precipitation water gets converted into the vapor. This much losses are there. But there are various methods to reduce the evaporation losses. They are the reduction of the surface area, mechanical covers, and chemical films. So either providing the mechanical covers or by uh, increasing the depth of water or by providing the chemical films, we can reduce the evaporation losses. Mainly the cetyl alcohol type B chemicals are used, are sprayed over the water body, over the surface of water. You keep this name in your mind. Cetyl alcohol is the evaporation control chemical. How to measure the evaporation? There are various methods are there. The main is the evaporimeter or the pan evaporation. Empirical equations are there. Analytical data are there. These are the pan evaporimeter. They are called as the evaporation pans. They are nothing but the a, a either a plate, a container like the cylindrical container, which is about 1 to 1.5 meters of diameter and about 0.25 to 0.30 meters of the depth. It is either kept adjacent to the reservoir or can be kept in the meteorological stations. The water is poured into this and the depth of water that has been evaporated is measured with the help of certain measuring gauge is being observed, and this equipment is called as the evaporimeter. There is one coefficient called as the pan coefficient. Indian standard evaporation pan is there whose diameter is 1.1.22 meter or 122 centimeter is the diameter. Its depth is 25.5. There is one gauge which is called as the stealing well, which measures the water that has been evaporated. As this equipment is placed, these are all the details of that equipment. As this equipment is placed adjacent to the reservoir so as to find the evaporation through the reservoir. But the conditions of the reservoir are different than the conditions of this pan evaporimeter or pan equipment, evaporation pan. There is one constant called as the pan coefficient, which gives the exact quantity of the lake evaporation, which is equal to lake evaporation or evaporation from the reservoir is equal to pan coefficient multiplied by pan evaporation. There are various types of the pans, Colorado sunken pans. There is another floating pan. Next is the transpiration, that is the evaporation of the water from the plant leaves. Okay, this is called as the transpiration. It is very well explained here. The plant leaves has got the holes, all the small openings. They are called as the stomata. Through this stomata, due to the sun rays or solar radiation, sun heat, the water that has been absorbed through the roots by the plant for its growth gets evaporated through these openings. It is called as the transpiration. So through this process also lot of the water is being lost. So therefore the importance of the transpiration. Again, various factors which affects the evaporation are affecting the transpiration. There are various methods to measure the evapotranspiration only. They are called as the phytometer method, wherein some artificial conditions are created so as to find out the water that has been lost via transpiration. These are the phytometers. Then the combination of both these two, that is the loss of the water through evaporation transpiration, is called as the evapotranspiration. It is also called as the consumptive use. It is the evapotranspiration, that is the combination of the evaporation, transpiration, as well as the water that has been used for the metabolic process of the plant development or the plant tissues. Okay, so that is called as the evapotranspiration or the consumptive use. It is divided into two parts: potential evapotranspiration, actual evapotranspiration. Then the factors which affects the evaporation and transpiration affects the factors affect on the evapotranspiration, that is the weather parameter, crop characteristics, management and the environmental, whether in weather, radiation, air temperature, humidity, wind speed, etc. Crop characteristics also there are there. So various factors. The determination of the evapotranspiration. Again, there are various methods: water budget method, field experimental plot, soil moisture, and lysimeter method are there. So lysimeter is one of the, again, creation of the artificial plots wherein water is being left over the measured or known plants, and the evaporation and transpiration loss is being found out with the help of all these lysimeters. There are certain formulas based on the climatological data. They are the Blaine-Creedle formula, Thornwhite formula, Christian Penman, evapotranspiration. Various formulas are there. But in our India, we use the formula prepared by Mr. Penman. It is also approved by the Food and Agriculture Organization (FAO), which is part of the United Nations. Now there are, when the precipitation occurs over the earth, 100% of the precipitation does not get converted into the runoff. Some part is being lost in between, means from the source, that is clouds, to the earth. That lost part of the precipitation is called as the abstractions. These are divided into the 6 parts, that is the interception, evaporation, transpiration, infiltration, depression storage, and watershed leakage. Interception means loss of water due to the obstruction in between the cloud and the ground by either the buildings, due to the plants and trees. Evaporation means the conversion of the water either from the land or from the trees or from the building due to the vaporization. Transpiration is loss of water to the plant leaves. Infiltration means some water after saturation of the soil gets seeped or it seepages into the ground. that is called as, or percolates, that is called as infiltration. Certain water is stored into the certain small ponds, reservoirs, or certain pits. These are called as the depression storage. And certain water leakages from one catchment area to another, that is called as the watershed leakage. So these are the various abstractions needed to be considered while working out the runoff. Now the next is the infiltration. Infiltration is the process wherein the water on the ground surface enters the ground through the soil surface or through the pore, that is called as the infiltration. Infiltration rate is the rate at which the soil absorbs the water, or the percolation of the water occurs into the soil initially at a faster rate as the soil is dry. So the infiltration rate is more. As the soil gets saturated, as the soil becomes wet and wet, then the infiltration process decreases. So we can say infiltration rate decreases. So when the precipitation, this infiltration is also measured in centimeters. So precipitation is measured in centimeter. The evaporation or evapotranspiration is measured in centimeter, that is depth, and the infiltration is also measured in centimeter or the depth. So when the precipitation rate or the rainfall rate is more than the infiltration rate, then the water gets converted into the flowing water, which is called as the runoff. So when this condition comes, then the runoff generally occurs. As I have told you, infiltration is the process of the percolation of the precipitation water or the rainwater into the ground due to, first, the ground or the soil gets refilled or replenished due to the soil moisture, and then it percolates. When we plot a graph between duration or the time and the rate of infiltration, then that graph is called as the infiltration capacity curve, or it is called as the infiltration curve. And the maximum rate at which this infiltration occurs, that maximum rate of infiltration is called as infiltration capacity of the soil. And as you can see, initially, as the soil is dry, the infiltration rate is more. So initially the maximum rate is called as the infiltration capacity. That is the maximum rate at which the water will enter the soil in a given condition. So this infiltration capacity curve or infiltration rate curve is very important. There are the effects of the infiltration. The main effect is it reduces the flood. It percolates the water into the soil, which is very helpful from the point of view of the forest or the greenery. It increases the groundwater table. It reduces the soil erosion. So all these are the good effects or the effects of the infiltration. There are various factors which affects the infiltration. Again, the ground surface, whether it is forest, vegetative cover or dry or the bare, permeability characteristic of the soil, that is the geology, antecedent moisture condition, means before the rainfall occurs, what was the soil, whether the soil is moist, the atmospheric temperature, intensity and duration of rainfall, movement of the man and animal. All these are the very important factors. The catchment parameters, where the catchment has got lot of the depressions or the storages, that also affects to the infiltration. There are various methods to measure the infiltration. Infiltration is being measured by the runoff estimation, soil moisture budgeting, and the irrigation. The various methods are flooding type infiltrometer with the measurement of subsidence of free water in the large basin, rainwater simulator, hydrograph analysis. These are the various methods, various hydrograph analysis. In various hydrograph analysis method, the infiltrated water, which is called as the best flow, is being separated out from this hydrograph, storm hydrograph, which is also nothing but a graph between the duration or time and the runoff at certain location, wherein this is the portion which is shown in dark shade, dark blue, is the infiltrated water. There are certain equipments called as the infiltrometers. There are two types of the infiltrometers: flooding type infiltrometer and the rainfall simulators are there. Flooding type are also further divided into single ring and double ring of the infiltrometer. The fundamental of all these infiltrometers is that the water is being poured in this container, maybe a diameter of say 25 to 30 centimeters and the height is 50 to 60 centimeters. It is put into the ground and water is poured into this infiltrometer, and the percolated water is being found out along with the time and the percolation rate and the infiltration capacity of the soil is being found out either with the help of the single infiltrometer or the double ring infiltrometer. In double ring infiltrometer, the disadvantage due to the single ring is being overcome, and therefore the measurement of the loss of water in the central container is being found out in the double ring infiltrometer. There are certain rainfall simulators are there, wherein a certain plot is selected, and on this selected plot, artificial precipitation with the help of the sprinkling of water is being carried out, and the infiltration is being found out. There are certain indices, they are called as the infiltration indices. There are two types of the infiltration indices are there. They are the phi index and the W index. The phi index is nothing but the index below which, if we overlap this phi index value, it is nothing but a rainfall intensity. It is nothing but a rainfall rate, that is centimeters or millimeters per hour. If and this phi index is constant for a certain catchment area, the W index is constant for a certain catchment area. These two indices are nothing but phi index is the precipitation rate or the rainfall intensity, and the W index is nothing but the infiltration rate. So both these indices are used to find out the exact quantity of the runoff. Okay. Phi index gives, after deducting the value of the phi index or the rainfall intensity for a particular duration from the rainfall quantity, whatever remaining quantity we get, that is the surface runoff. But W index is more precise than the phi index, or it is less than the phi index. The W index value excludes all the other abstractions below this phi index value, or the phi index includes infiltration plus other abstractions like the interception, depression, storage, etc. But W index value is purely the infiltration rate. It does not include other abstractions. So these are the uses of the phi index and the W index, mainly to find out the quantity of the runoff from the hydrograph or from the rainfall data. Okay, if we have the rainfall data, that maximum quantity of rainfall for certain duration, then from that rainfall data, after deducting the phi index value or after deducting the W index value, we can find the runoff values, which are of prime importance to us for the design of our hydraulic structures. So they are very important. So friends, the remaining part, that is the hydrographics and the unit hydrograph, we will discuss in our next lecture.